The next question is question number 168, which says the correct difference between first and second order reactions is that. The statements are, the first statement is the rate of a first order reaction does not depend on reactant concentration. The rate of a second order reaction does depend on the reactant concentrations. Second is the half-life of a first order reaction does not depend on A0, that is initial concentration of reactant. The half-life of a second order reaction does depend on A0, that is initial concentration of reactant. Third statement is the rate of a first order reaction does depend on reactant concentrations. The rate of a second order reaction does not depend on reactant concentrations. The fourth statement is a first order reaction can catalyzed, a second order reaction cannot be catalyzed. These are the four options. Let's understand the relation of half-life with the initial concentration. Initial concentration is A0, then T half is directly proportional to A0 to the power 1 minus n. If it is first order reaction, then T half is directly proportional to A0 to the power 0. If it is second order reaction, T half is directly proportional to A0 to the power minus 1. So here we can see T half of first order reaction is independent on initial concentration and second order reaction depends on the initial concentration. So the correct answer for this question is option 2. The half-life of a first order reaction does not depend on A0. The half-life of a second order reaction does depend on A0. So answer for this question is option 2. Now let us move to the next question. The next question is question number 169, which says in which case is number of molecules of water maximum. First option is 18 ml of water, second option is 0.18 gram of water, third option is 10 to the power minus 3 mole of water, fourth option is 0.00224 liter of water vapors at 1 atmosphere and 273 Kelvin. Now let's solve this question. Let us calculate the number of moles. With the help of number of moles, we can easily identify which will have the higher number of molecules. In the first case, 18 ml of water means we have 18 gram of water because density is 1. So 18 gram water divided by mass is 18, that is equals to 1 mole. In the second case, we have 0.18 gram of water. So 0.18 divided by 18 will give us 0.01 mole. In the third case, we have 10 to the power minus 3 mole of water. 10 to the power minus 3 mole. And in the fourth case, we have water vapors at 1 atmosphere and 273 Kelvin temperature. Here we know that 22.4 liter is the volume of 1 mole of the gas. So in fourth case, we'll have 0.00224 divided by 22.4. That will be equal to 10 to the power minus 4 moles. So maximum number of moles is in case of option 1. Therefore, the correct answer for this question will be option 1. Answer is option 1. Now let us move to the next question. The next question is question number 170, which says among CH2, BH2, BH2, the order of ionic character is. The options are given. Students, as we know, as we move down the group, the metallic character increases. Hence, the ionic character of hydride should also increase as we move down the group. So the order should be beryllium hydride, should be least metallic, then calcium hydride, and in the end we have barium hydride, which is most ionic. So the correct answer for this question is option 1. Now let us move to the next question.